causal relationship from a correlational study. Let me explain what I mean by using a fictional story. Imagine a king who rules over a vast country. Because the king is a kind king, he would like for all of his citizens to be as healthy as possible. He issues a survey to each town asking for the number of doctors they have and the number of illnesses they've had that year. Upon receiving the survey back, he is shocked to find that the fewer doctors the town had, the fewer illnesses occurred. Wanting to have the healthiest population possible, he quickly orders that all towns with too many doctors get rid of half their doctors. Not surprisingly to us, this action does not decrease the illness in his kingdom, but actually increases it. But why? The king made a mistake that many journalists now make. He assumed that the number of doctors was causing the increase in illness, when in fact, the number of doctors was only related to, or correlated to, the number of illnesses in each town. Us being the intelligent individuals that we are, have likely guessed that in fact, the relationship is reversed, and that when more illnesses are present, more doctors are needed to cure them, accounting for the higher number of doctors in towns with many illnesses. You can see how the consequences of this type of mistake can often be detrimental. While the king's failure may seem obvious, we sometimes will overlook these issues when reading a misleading news article. A recent article published by Fox News presents misleading information about one of the most important things to us, our children. In a recent study, Dr. Angie Page looked at over 1,000 children ages 10 through 11. Her study looked at two main variables: how many hours they spent in front of the TV or computer screen every day, and the degree of psychological difficulty they had. The study found that children who spent more than 2 hours a day in front of screens were 60% more likely to have psychological difficulties than those who spent less than 2 hours a day. The article leads the reader to believe that spending time in front of the TV screen will cause a child to have psychological difficulty. However, upon closer examination, we can see that this is not necessarily the case. We simply don't know which variable is causing the other. It could be the case that psychological difficulty leads to children spending longer time looking at screens, a possibility that the article fails to mention. There is also a third possibility that the article fails to entertain: the possibility that psychological difficulty and TV watching are both side effects of some other third variable.
Okay. Oh.
Later. The news reporter fails to address these possibilities, and instead focuses on the more alluring causative relationship. As a consequence, many psychologically unhealthy children everywhere may come home after a tough day.
Okay. So that's kind of just an example of why you can't just jump to conclusions and say that A causes B, and you have to look at all the other factors. So, next thing is sample size. So, obviously, when you're doing an experiment, it's the reason that, when we were doing this orange disease or whatever, that we took 100 people is because you can't take all people in the world and test them and see if what's causing what. You just need to take small sample size and then compare it to a larger one. So, okay, so in my textbook it says, the more participants that are in a study, the more likely it is that the researcher will see a true effect of an experimental treatment, even if it is very small. For example, a study of over 21,000 men over 6 years in Finland demonstrated that men who took vitamin E supplements had 5% fewer colds than the men who did not take the supplements. In this case, the large sample size allowed researchers to see that vitamin E has a real but relatively tiny effect on cold incidence. So there was a big margin of error, obviously, but sometimes those things can help us. They can help us see that those are factors in something, and even though it doesn't mean that it caused it, they can help us to learn. So, let's see. Alright, so then once you've come up with all those things, you can come up with your conclusion, and you can say that your evidence supported or did not support your hypothesis. So you can't say that you proved something. And once you've gotten to that point, in order to have a reliable experiment, you have to keep trying it over and over again to make sure it can't be disproved. And you want it to be peer-reviewed by an expert. and someone that knows what they're doing. So now we're going to talk about 3 types of evidence. So there's primary, secondary, and anecdotal. So does anyone know what a primary source is?
When you did an experiment for yourself and you see it for yourself, you're not getting it from anybody else.
Yeah. So it's very direct. It's peer reviewed. What else? And you've tried it over and over again, so it's repeated. And secondary is obviously indirect, and so that's more like, well, does anyone, oh, okay, so anyway, does anyone know what an anecdotal source is? Yeah.
An anecdotal is like a one-time thing.
Yeah.
Like.
Yeah.
Okay, so can anyone think of an example of a primary source?
Like a journal?
Yeah.
Or what kind of thing are you asking?
Yeah, like a journal.
Like a testimony, like something that happened.
A testimonial would actually be anecdotal.
Oh, okay.
Yeah, thank you though. Very helpful, Maddie. What about secondary source? Okay.
A book.
Well, yeah. A book, a newspaper, just an article. So the difference is that a primary source would be something like if the researcher is telling you I did this, this, and this, and they're just explaining all their entire experiment in detail. And then a secondary source would be like, for example, your orange disease example again. Maybe you finally get a good experiment and you've repeated it and everything, and it's pretty good. So the local newspaper decides to write about it. And so they're not going to say every single thing you did in your own words. They're going to summarize it and then talk about other stuff. And so that would be a secondary source. An anecdotal would be if someone said that they gave a little testimony about how, eating more oranges increased their chances. Like maybe no one in their family except for Joe likes to eat oranges, and so Joe was the only one in the family that got the orange disease. So we're going to watch. Where is it? Oh. Oh, sorry. Okay, so this is just going more into depth about primary and secondary sources.
Let's say you have an assignment that requires both primary and secondary sources. How do you identify those, and where do you find them? Chances are that you're familiar with a variety of primary and secondary sources and use them in everyday life. However, locating primary sources about an academic topic can sometimes be difficult. So what are primary sources? Primary sources are first-hand accounts of an event and are created during the time that event took place. They can also be created retrospectively at a later date by a participant in those events. They are original documents and usually don't describe or analyze other documents. They can also be creative works. Some examples of primary sources are speeches, laws, and court documents, diaries, memoirs, autobiographies, and letters, works of art, novels, and plays, documented observations, interviews, original research, and data, and historical newspapers. So how can primary sources be used for research? They can be used as a focal point of a discussion about events. They can be used to back up claims or criticisms. They can be used as evidence for theories in research, and they can be used to gain historical perspectives on a topic. So what are secondary sources? Secondary sources are written by scholars or observers after the fact and interpret or analyze primary sources or events. These sources are at least one step removed from what they are describing. Some examples of secondary sources are textbooks, encyclopedias, essays, and reviews, magazine or journal articles which analyze events or ideas, and books which provide a summary of events or synthesize information from many primary sources. So how are secondary sources used? They can be used to get background information and understand the scope of a topic. They can be used to see what others have discussed or get opinions. You can use them to learn how recent events affect or fit into the larger picture. And they can help you understand the significance of events, data, works of literature, and art. Let's look at an example. A primary source for a paper about the placebo effect could be data from a medical trial which was published in an academic journal. Secondary sources for this topic could include books about medication, the placebo effect, and health in general, or websites which define various anxiety disorders. One thing to keep in mind is that a source's classification as either primary or secondary can change depending on the topic that you're studying. For example, if you are writing about how the news is being represented on the internet, a news site like CNN might be considered a primary source. If you're studying news on the internet, CNN.com represents the object that you're studying. However, if you're writing about political elections and you find an article on CNN.com that analyzes them, the article would be considered a secondary source. Since in this case you're studying the elections, an article on CNN.com is one step removed from your topic. For an effective research paper, try to use both primary sources, sources that are an original source of data, historical information, or creative works, as well as secondary sources, sources which summarize, analyze, or comment on ideas or events.
Okay. So, okay. So now we're just going to do a quick little recap on everything. And so, just really quick, so what we learned was that the scientific method, there were three main parts. The first part was your hypothesis, and before that you have to do observations. The second part was actually testing it with an experiment, and there are different ways, different sorts of experiments that you can do. And then the third thing was just coming to a conclusion and making sure that your data was reliable, and also repeating it. And then we also talked about inductive and deductive reasoning. And so I just have a little example, and so I'm going to ask you if it's deductive or inductive reasoning. So, let's say that you made some really delicious brownies, and you were so excited, and you left them out on your kitchen counter, and then you come back, and they're all gone. And
deductive.
And so you're kind of like, you're kind of upset and you're trying to find out who did it. And then your roommate, I don't know, let's name her Sally. Roommate Sally walks in. She has chocolate all over her face. And you ask her and she says, no, I didn't do it. So, and then you go into her room and you find brownie crumbs all over the place. So what would that be? So would that be inductive or deductive?
Inductive.
Yeah. Okay. Inductive. So now let's say that you take DNA from the cookie crumbs on the counter. Would that be? And you find out that it's her. Okay. So that would be deductive. Right. Okay. So anyway, just to kind of wrap everything up, basically, there are questions that we have in our everyday lives to things that affect us, like diseases and things like that, and science can help us find cures or ways to treat things in our everyday lives. So, yeah, that is it.